Okay, hello guys, so this is section 2.1, the distance and midpoint formula. And first we're going to start with definition of the distance. So the distance between 2 points P1, which has coordinates x1, y1, and P2, which we're going to mark the coordinates with x2, y2. So we just x1, y1, x2, y2 just represents the index, just to make sure that they are different. Denote by d, which states for distance, in parentheses p1, p2. So we read that as a distance between points p1 and p2 is, and this is the distance formula, distance between 2 points p1, p2, we're calculating using the formula square root, and under square root we have x2 minus x1 square plus, in parentheses, y2 minus y1 square. So this is the distance formula which we need to memorize between 2 points. Okay, so distance between 2 points. And that's the formula. Next definition. So first I will give you the definition, then we'll practice. The next definition will be the definition of midpoint. So I will give you the midpoint formula. So this one was distance. Next one is midpoint formula. Okay. So the midpoint M, so midpoint, it's a point on the coordinate plane, which has, we're talking about 2 dimensions, x comma y, of the line segment from point P1, which has coordinates x1, comma, y1, to point P2, which has coordinates x2, comma, y2, is, and this is the formula for a midpoint. Midpoint, it's a point on the coordinate plane. That's why you see x comma y, because we're going to find the coordinates of the midpoint, equal. And this is how you're going to find those coordinates. You're going to add coordinates of point P1 and P2 and take the average of them. So that means x1 plus x2. I'm adding the x coordinates of those 2 points together and divide by 2, which you may think about, I find the average of them. And to find the y coordinate, I'm adding y coordinates of point P1 and P2 and divide that by 2. So this is the midpoint formula between 2 points. Okay, also has to be memorized. Midpoint. And now we're going to use those 2 formulas and practice problems. So let me start with example 1. we need to find the distance d between the points and P1 has coordinates 3, comma, -4, so that's the first point. And the second point, it's P2, which has coordinates 5, comma, 4. So we need to find the distance between those 2 points. So you don't need to draw the coordinate plane, but I'm just going to draw one so we understand what we're doing. So we have coordinate plane, okay? 1, 1. Okay, so my P1, the first point, has coordinates 3, comma, -4. Okay, 2, 3, comma, -4. 1, 2, 3, 4. Okay, so this is P1. The second point, P2, right here, has coordinates 5, comma, 4. 1, 2, 3, 4. So this is P2, the second point. So what we're trying to do, we're trying to find the distance between those 2 points. Again, you don't need to draw the coordinate plane, but I'm trying to explain it that if we'll try to connect those 2 points, we want to know what is the distance between them. What is the distance? Okay, so that right here will represent the distance, the equal distance. So this is what we're trying to find. Okay, so to find the distance, we're going to use the distance formula. So the distance formula between 2 points equal square root x2 minus x1 square plus y2 minus y1 square. Okay, so this is what we're going to do. The first point P1, 3, you're going to represent x1 from the formula. -4 represents y1 from our formula. Okay. Now, when we talk about point P2, which is our second point, 5 represents x2 from the distance formula. 4 represents y2 from the distance formula. So let's just substitute. So we have square root and we have x2. So again, x2 was 5 minus x1, which is 3, parenthesis, and we're going to square it, plus y2 minus y1. So y2 it's 4 minus y1, which is -4, close parenthesis, and square it. So this is how the distance formula looks like. x2 minus x1 plus y2 minus y1. So first what you're going to do, you're going to simplify the expression under square root. So we have 5 minus 3, which is 2. And then we have 2 to a second power. Plus, from the second parenthesis, you have 4 plus 4, because 2 negatives gives you plus, so we have 8 square. And that will give us 4 plus 64, which is square root of 68. And you always want to simplify. So square root of 68, you want to break it down as a square root of 4 times 17 will give you 68. So square root of the product, it's equal to the product of square roots, which means you have, this is the same as square root of 4 times square root of 17. And square root of 4, it's 2. Square root of 17, it's irrational, so you just copy that way. So that means this is 2 times square root of 17. And when you're solving problems, again, always simplify that radical. If you will enter the answers as square root of 68, you won't get credit. Okay, so you need to break down 68 into, so at least one of the factors of 68, it's a perfect square. Okay. Okay, so this is the solution. So this is the distance. The distance between those 2 points, it's 2 square roots of 17. Okay, now the next problem, which I want to do, example 2. In this example 2, I took it from your textbook. This is from our textbook on page 155. This is number 37. So if you want to just read it and or solve more problems like this. So here in this problem, they ask to find the midpoint of the line segment joining points P1 and P2. Okay, P1 and P2. Okay, so we're going to find the midpoint. So what is given in this problem? They give you the coordinates of point P1, which is 3 comma negative 4, and they give you the coordinates of point P2, which is 5 comma 4. Okay, and we need to find the midpoint. So again, I just going to graph it just once, since just to explain it how midpoint looks like. It's just a point in the middle. So P1 is 3 comma negative 4. This is P1. And we have P2, which is 5 comma 4, 3, 4, 5, 1, 2, 3, 4, right here, P2. And we're saying find the midpoint of the line segment. So what we have the ends of the segment. If you will connect those 2 points, this is the line segment. So the midpoint, which we're trying to find, okay, it's going to be the point in the middle. So we're not going to take a ruler and just find the middle, but it's going to be somewhere here, okay? So we're trying to figure out what will be right here. What are the coordinates of the midpoint? Okay, so here it's a midpoint, which has coordinates x comma y. We're trying to figure out what are the coordinates of that midpoint using midpoint formula. So midpoint formula is, again, we'll get the point which is in the middle of that segment from P1 to P2. Midpoint formula is x1 plus x2 divided by 2, comma, and that will give you that x, coordinate y1 plus y2 divided by 2. Okay, so again, you're going to label, okay, 3, this is x1, negative 4, it's the y1, 5 represents x2, and 4 represents y2. So we're just going to plug it in. So we have x1 plus x2, so we have 3 plus 5, everything divided by 2, comma, y1 plus y2 divided by 2, which is negative 4 plus 4 divided by 2. And that will give us 8 divided by 2, which is 4, comma, 0 divided by 2, which is 0. So the midpoint, so that's the coordinates of the midpoint. So my sketch was wrong because the midpoint, the point in the middle, it's negative, it's 4 comma 0. So let me fix it. Okay. So it's better. So right here, it's that midpoint. Okay, so that's the midpoint. Okay, midpoint. Which right now we have now that has coordinates 4 comma 0. Okay, so the point in the middle. So nice formula to use it. I think those two problems were so far good. You guys just have to plug in into the formulas. Let's do a little more. Let's practice. So that will be the exercise 3. And this one also I took it from your textbook. This is page 155, number 31. Okay. So plot each point and form the triangle ABC. Show that the triangle is a right triangle. Finds its area. Okay, so here in this problem, they give you point A, which is negative 2 comma 5. They giving you point B, which has coordinates negative 1 comma 0, and they give you point C, which has coordinates 1 comma 3. So first what we need to do, we need to create a coordinate plane. Okay, so A, negative 2 comma 5. Negative 2 comma 5, 1, 2, 3, 4, 5. So here we have A. B, negative 1 comma 0. So this is negative 1 comma 0. So this is point B. And C, 1 comma 3. 1 comma 3, C. So we have ABC triangle. And what we're trying to do, we're trying to show that this triangle, it's a right triangle. So again, this is just a sketch, but I'm assuming if this triangle will be the right triangle, okay, right here is going to be that 90 degree, okay, at least based on this picture. So show that the triangle is the right triangle. So what we know about the right triangles, you guys definitely know the Pythagorean theory. So this is how we're going to approach that problem. To show that triangle ABC is a right triangle, show that, and again we apply the Pythagorean theory. So we're going to show that C squared, which is the longest side of the triangle, it's equal A squared plus B squared. So we're just going to show this is the Pythagorean theory. And that only works for the right triangle. So let me start labeling. Okay, so when we have that segment 8B, A and B, let's put it that way. When you guys see the right here, vertex A, the side right across, we're going to label with lowercase a. So this is A. The distance between B and C, we're going to call A. Now, when you see vertex C right here, the side of the triangle right across of that vertex, we always label with the letter C, lowercase. So this is C. And in orange, C, that's fine. And in orange, again, that's vertex B. So the side right across of it, we're going to label with B. Right here. So again, like we see, based on this picture, our sketch, yes, hypotenuse of the triangle is the longest side, which is C. So we have to show that C squared is equal A squared plus B squared. So first what you need to do, we need to find the length of side C, which is in green, which is a distance between 2 points, between A and B. Okay, so again, to find that C represents the distance, so I'm going to put it that way, between points A and B, and I'm going to use the distance formula, which is square root of, again, x2 minus x1 square plus y2 minus y1 square. So I'm using the distance formula. So A, the coordinates of vertex A of the triangle are -2, 5. B, the coordinates of vertex B of the triangle are -1, 0. So again, don't forget that -2 is your x1, 5 it's your y1, -1 it's your x2, 0 it's your y2. So we're just going to substitute them into the formula. Again, C represents the distance between A and B, so I'm using the distance formula. So here we'll continue. So that will give us square root x2 minus x1. So we have -1 minus x1, which is -2, and everything has to be square root, plus y2 minus y1, which is 0 minus 5 square root. And then everything is under square root. So that will give us first simplify the expression under square root. So we have -1 plus 2. So that will give us 1 to a second power. So we have 1 square plus -5 square. And that will just give us 1 squared is 1, -5 squared is 25, so 1 plus 25, square root of 26. So we end up with square root of 26. And square root of 26, we cannot really simplify. So let's just remember, let's just say that the square root of 26, it's our C. That's C. Okay, let's put it that way. Which means what we just find it, I find that the length between point A and B, it's equals square root of 26. Okay, now what I'm going to do, I'm going to find B. B represents the distance between point A and C. So again, B is the distance between points A and C, and I'm going to use the distance formula, the same thing. x2 minus x1 square plus y2 minus y1 square. Okay, and we'll go back. A has coordinates -2, 5. C has coordinates 1, 3, and -2, that will be my x1, 5 will be y1, 1 will be x2, and 3 will be y2. So I'm going to find that distance B. Okay, which is, I'm going to find the length of side B, which is the distance between those 2 points. So again, B is equal, let's plug in into distance formula, x2 minus x1. So we have 1 minus -2 square plus y2 minus y1, which is 3 minus 5 square. And that will give us square root 1 plus 2, it's 3, 3 to a second power getting 9. 3 minus 5, we end up with -2 to a second power, that will give you 4. So we have radical of 9 plus 4, which is the square root of 13. So let's say that this is B. The length of side B is square root of 13. So let me put that on the picture. Right here, B, right here, we know it's equals square root of 13. And the last one, what we're trying to find, the length between points B and C, which is our side A from the Pythagorean theory. So I'm going to find the distance between point B and C, which will give me the length A. So A, it's a distance between points B and C, or you can put C and B. The order doesn't matter. B and C. And we're going to use the distance formula. x2 minus x1 square plus y2 minus y1 square. Okay. So going back, let's label that B, let's go back and review. B has coordinates -1, 0. And C has coordinates 1, 3. So the first one you're going to label as x1, y1. The second point you're going to label as x2, y2. And we're just plugging in into the distance formula. So we have under square root x2 minus x1, which is 1 minus -1 square plus y2 minus y1, which is 3 minus 0 square. So simplify, so we have 1 plus 1, it's 2, 2 to a second power getting 4, and again 3 to a second power will give us 9. So we have radical 4 plus 9, which is square root of 13, and this is the length of side A. So this side of the triangle, it's equals square root of 13. Now, when we know all 3 sides of the triangle, which we're trying to prove it's a right triangle, so now we'll go back to the Pythagorean theory, and I need to show that c squared is equal a squared plus b squared. So next, show that is true that c squared is equal a squared plus b squared, which is the length of the hypotenuse of the right triangle, square root, it's equal to the sum of squares of two other sides. So C, we calculated already, going back to the picture. C, it's equal to square root of 26. So I have square root of 26, that's C, and I'm going to square it. Supposed to be equal, so I'm checking if this is true. A to a second power. So A is equal radical of 13. And I need to square that, plugging it into Pythagorean theory, plus B to a second power. So B, we calculate, was radical of 13. Okay, and now just show that this is true. Square root of 26 to a second power, this is just 26, equal square root of 13 to a second power, it's equal 13, plus square root of 13 to a second power, this is 13. So we have 26, it's equal 26, which is true. So we just prove it. Yes, the triangle ABC is the right triangle because satisfy the Pythagorean theory is the right triangle. Because each right triangle always satisfies the Pythagorean theory. So it was a long problem just to trying to prove it and show how we prove that the given triangle is a right triangle. Okay, so we continue. I think this topic, this section is not so bad. There's not really such a heavy-duty algebra. It's more like the concept from geometry, but actually to figure out the answer, we need algebra. Okay, so I guess let's practice a little more for those who need more practice. Next one, example 4. I took that from your textbook also. This is page 155, number 49. Okay, and a little different problem. Still, we'll apply distance and midpoint formula, but a little different. Find all points on the x-axis that are 6 units from the point 4, comma, -3. So here, this is different because look what happened. I'm only giving you 1 point, 4, comma, -3. And what is different about this problem that I'm giving you distance. That 6 units represents distance. So this is the distance. So we have to find point or points which have 6 units distance from the given point. Okay, so you may assume that 4, comma, -3, let's say this is point P1. So we need to find the other point. Okay, we know that the distance between those points has to be 6. So again, maybe just to see it, let me just draw the coordinate plane so we can see a little better. So what is given? We have a point 4, comma, -3. So this is that point P1. And we're trying to find the other point, which is 6 units away. from this point. Again, so why we using plural here? Because look what happened. We can find that point either going that way, and again, it doesn't have to be on the vertical line. It can be slant line, let's say. Sorry. So let me just draw it and then I'll erase it. Again, we can go 6 units that way, and that will be our point. Okay, or we can go 6 units that way, right? We can measure 6 units and we can find this point. Okay. Or we can just go that way, 6 units, and find this point right here. So that's why we're using plural. So we know we have only one point, which is given P1 with coordinates 4, -3. Okay, so this is given and we know distance. So again, let's just write this down. Given. Distance is given. Distance is equals 6 units. And one of the points is given, P1, which is 4, -3. Since distance is given, of course, we're going to use distance formula to find the coordinates of the other point. So the distance formula again. So the distance between points P1 and P2. So we're trying to find the coordinates of point P2. So I don't know those coordinates. So I'm going to label that as x2, y2, okay? Because we're trying to figure out those coordinates. So, and the distance between P1 and P2, we know it's equal 6, okay? So the distance formula, square root, x2 minus x1 square plus y2 minus y1 square. Okay, so the given point P1, 4 will represent x1 from the distance formula, -3 will represent y1 from a distance formula. And again, we know that the distance is equal 6, so we have 6 equal, and let's just plug it in. x2 minus x1. So x2 minus 4 square plus y2 minus y1 square. Okay? Okay, so now what we need to do Okay, now before we continue, okay, I want to go back to the problem because I almost forgot about very important details. Find all points on the x-axis. So I forgot about this, that are 6 units away from this point. So look what happened. This is your P1. So we will have two solutions. Our points have to be on the x-axis. So it can be this point, it's your P2, or it can be, let's say, going 6 units that way, that also P2. So we're going to have two solutions. Now, what we know about those points, that they are on the x-axis. So we know that x2, y2, we're trying to find the coordinates. So since the points which we are looking are on the x-axis, so we definitely know that that x2 has to be equal 0 since it's on the x-axis. So our points which we're trying to find will have coordinates 0, y2. Okay, the same thing here. This point, again, it's on the x-axis, so it's going to be 0, comma, y2. So we technically have to figure out what will be the y coordinates. Oh my god, opposite. So guys, again, coffee. I need coffee. Not here. Forget for a second what I said. Okay, look. The same thinking, I just messed up. Since our point, it's on the x-axis, right? Go back. The one which we're trying to find, so look what happened. So we're going 16, so maybe that will be 10, comma something. So the y coordinate of those 2 points, P2, the y coordinates of our 2 points, P2, and this P2, it's 0. Okay, so we have x2, comma 0, the height is 0 because we're on the x-axis, and P2 will be x2, and y2 will be replaced with 0. So right here, when I describe the points which we're trying to find by P2 is equal x2, comma y2, we're going to mention that y has to be equal 0 because those points are on the x-axis. So this is just x2, comma 0. Okay, so when we had y2, we're going to replace that with 0. So we have 6 equal square root x2 minus 4 square plus y2, which is 0, minus minus, which is give you plus 3 to a second power. And now we're going to solve this equation for x2, which will give us the x coordinates of the points which we're trying to find. So look what happened. You don't want to have a square root, so we're going to bring both sides to the second power. Because second power and square root, they aren't doing each other. So this one, bring it to a second power, and entire expression on the right side, bring it to a second power. And that will give us 6 squared, which is 36, equal second power radical cancel each other, and we have x2 minus 4 squared plus 0 plus 3, which is just 3, plus 3 squared. So simplify, we have 36 equal. Here you will have to FOIL, so this is x2 minus 4 times x2 minus 4 plus 9. So again, don't forget that x2, this is just index 2, it's not x squared. So we're going to FOIL here. So we have 36, it's equal x2 times x2, that will give us x2 square. Okay, now x2 times negative 4, that will give us negative 4x2. And then you have negative 4 times x2, which will give you negative 4x2. And negative 4 times negative 4, that will give you 16. And don't forget that we still have that plus 9. Okay, so let's simplify. We have 36, it's equal x2 square minus 8x2 plus 16 plus 9, which is 25. Now what you want to do, this is quadratic equation. Just for simplicity, again, that x2, I'm just going to replace with x, so it's not going to get confused because this is just index, which represents the coordinates of the point which we're trying to find. So let me just drop it. So it's just easier to see it and solve it. So 36 is equal x squared minus 8x plus 25. Let's just leave it that way. So I will subtract 36 from both sides because we will need to solve quadratic equation. So we have x squared minus 8x. 25 minus 36. I'm just checking if everything is correct. But I think it is 25 minus 36. We're getting 11. Equals 0. Okay, so this one, I could solve a different way, but that's fine. So this one you won't be able to factor, so just solve it with quadratic formula. So let's review that quadratic formula. X equal negative b plus minus b squared minus 4ac divided by 2 times a. So let's plug it in. So we have negative b. So again, a it's equal 1, b it's equal negative 8, and c it's negative 11. So we have negative and b it's negative 8 plus minus square root, and we have b squared, which is negative 8 square minus 4 times 1 times negative 11, and divide each by 2 times a, which is 2 times 1. So from quadratic formula, we have 8 plus minus square root of 64 and plus 44 divided by 2. And that will give us 8 plus minus, we have 64 plus 44, we're getting 108 divided by 2. I'm sorry, square root of 108. And square root of 108, it's irrational. So let's see if we can simplify that. 108 divided by 3, we're getting 36. Okay, so we're going to break this down as 8 plus minus 108 is the same as 36 times 3. So we need to simplify that radical of 108. Okay, so again, let me show work here. Square root on the side. Square root of 108 is the same as square root of 36 times 3. And this is the same as square root of 36 times square root of 3. Square root of 36 is 6. Square root of 3 is irrational. So we're going to leave it that way, 6 square roots of 3. So we have 8 plus minus 6 square roots of 3 divided by 2. And now we're going to find two solutions. X is equal 8 plus 6 square roots of 3 divided by 2. And the second solution will be x equal 8 minus 6 square root of 3 divided by 2. Of course, you need to simplify. So divide each by 2. So this is 8 divided by 2 plus 6 radical of 3 divided by 2. So we're getting 4 plus 6 divided by 2, which is 3. 3 radicals of 3. And here we will get 8 divided by 2 minus 6 radicals of 3 divided by 2. So we'll get 4 minus 3 radicals of 3. So we have two solutions. What that means, okay? That means that the points on the x-axis has coordinates. The first one, 4 plus 3 radicals of 3. Don't forget that y2, because we're looking for the which are on the x-axis, have 0 as a y coordinate. And the second point on the x-axis, which is 6 units away from the given point, has coordinates 4 minus 3 radicals of 3 comma 0. So we find those 2 points. Okay. Okay, that's what we find. Okay, so we got two solutions because there are 2 points which are 6 units away from the given point. And again, in that problem, they tell you that they have to be on the x-axis. Okay, I think I will do one more similar to this one, and that will be the last one. So, which problem? So that's the last one. Last example, that will be example 5. Example 5. And this example I took from the textbook. It's on page 155, number 48. Okay, here they asking you this. Find all points having y coordinate of -6, which distance from point A, which has coordinates 1, 2, is 17. So what I recommended, to schedule that. Graph it. So see what is given, see what you have to find. Okay, so we have what is given. We have point A, which has coordinates 1, 2. This is point A given. And you have to find all points having y coordinate of -6, y coordinate equal -6, 1, 2, 3, 4, 5. So this is -6, which distance from point A, it's 17. Okay, so this is just horizontal line, y equal -6. Okay, so we're trying to find the point which have a distance from the given point 17. So again, since the y coordinate will be negative, so we'll have to just draw the segment going down. Okay, this is just the sketch, but we know that the distance between this point and this point is 17 units. Okay, and we know that the point which we're trying to find, our label with B, we don't know anything about the x coordinates. I'm going to label that with x. However, we know that this point has to have y coordinate -6. So we need to figure out what is the x coordinate of the point B, which has a distance 17 units away from the given point A. So, of course, we'll use the distance formula. You want to label the given point A as x1, y1. So x1 it's 1, y1 it's 2. And point B, that x, the x coordinate which we're trying to find, that will be the x2 from the distance formula. -6 will represent y2 from the distance formula. So again, we're going to use distance formula. So distance formula, in this case, we're talking about distance between points A and B. It's equal x2 minus x1 square plus y2 minus y1 square, and everything is under square root. Okay, so we're going to just substitute. We know the distance is 17. So this is 17 equal And now x2 minus x1, so x2, that's the coordinate of point B, which we're trying to find. We don't know it, so I will just put x minus x1. x1 is the x coordinate of point A, which is 1, square, plus y2 minus y1, so y2 is negative 6, minus y1, which is the coordinate of point A, which is 2, square, and everything is under square root. So let's simplify. So we have 17 equal square root x minus 1 square plus negative 6 minus 2, that's negative a to a second power plus 64. So you need to solve for x. To be able to solve it, bring both sides to the second power, because you don't want to have that radical. So we're going to bring both sides to a second power, 17 square, and entire expression on the right side to a second power. So we have 17 square, which is 289, equal, and radical and the square root undo each other. So we have x minus 1 square plus 64. And in this case, I'm not going to FOIL. I'm going to solve this using square root method. So it's quadratic equation. So to solve this one using square root method, let me just review it. So you want to only have this expression on the right side. Let's move everything else to the other side. So I will subtract 64 from both sides. Okay, so we have 289 minus 64. That will give you 225 equal x minus 1 square, because that cancel. And now to solve that, just take the square root of both sides. Okay, so this is square root method. So I'm going to take the square root of both sides. So square root of 225 will give you 15. And don't forget that when you take the square root of the whole number, you always have positive or negative solution. So that's why I'm putting plus and minus. And when you take the square root of the second power, that will just cancel and you end up only with x minus 1. And now just solve equation for x. So we'll add 1 to both sides, and we have that x is equal positive negative 15 plus 1. That means you will have two solutions. The first one will be 15 plus 1, which will give us 16. And the second solution will be negative 15 plus 1, which is negative 14. So this is what happened here. That's what your solution represents. Going back to this picture right here. Okay. I just showed you one scenario here that we're trying to find point B, which has distance 17 units away from the given point. But also look what happened. We can go that way, 17 units away, and that can be another point, okay? Which, again, we don't know anything about the x-coordinate of that point, right? We don't know what is that x-coordinate. However, we know that the y-coordinate of this point has to be also equal negative 6. So we also have two solutions. So you can find 2 points. The distance is 17. So the first point will have coordinates negative 14, comma. Again, don't forget that each point which we're trying to find based on that problem has to have the y-coordinate equal negative 6. So negative 6. And the second point which we find is 16 and negative 6. Okay, so we have two solutions. So I'm assuming that this one will be negative 14 comma negative 6, and this one will be 16 comma negative 6. Okay, so that's it from section 2.1. Hopefully, again, I went over a lot of problems from this section, so hopefully that will help you to study. Thank you for watching.